Hello guys, today we are going to solve problem. Check if it is possible to split array. So we have given a nums array of length n and an integer m, and we have to determine if it is possible to split array into n non-empty array by performing a series of steps. In each step, you can select an existing array with a length of at least 2 and split into two subarray. If for each resulting subarray, at least one of the following condition holds. Either first one, the length of the subarray is 1, or the second one, the sum of elements of subarray is greater than and equal to m. We have to return true if we can split the array into n arrays. Otherwise, we have to return false. So a subarray is contiguous non-empty sequence of elements within the array. So let's try to take these examples. So 2, 2, 1. So m is 4. So currently, if we are going to split 2 first and 2, 1 another, so 2 holds this condition true. These either one of these condition true, and because length is 1 and 2, 1 is sum is 3, so it doesn't hold this property. So it is going to be false. So now if we are going to split 2, 2, then and 1. So 2, 2 holds the property greater than equal to 4, and it is the length of 1, the another one. So so any one can be true. So here it is true. Similarly, if we are going to 2, 1, 3, so if we are going to split 2 and 1, 3 in second part, so it doesn't hold this either of these properties. And if we are going to split 2, 1 and 3 as a separate one, then also it doesn't hold any uh, true this property. So answer is false. Now we are going for 2, 3, 3, 2, 3, and m is 6. So obviously first we will try to split in this part because here 2 plus 2 4 and 6 10. So it is true. Now after this we can split into 2, 3, 3 and 2 further. So 2, 3, 3, and we can split further 2 and 3, 3 part, and then 3, 3 we can split. So just we have to make sure either one of these conditions should be true. So now let's try to look constraint. So we have constraint length is 100. So num value is 100 and m is 200. So if we take a look on this part, so it is kind of splitting the array into two parts, and we have to further look those of the parts whether they holds either one of the property as a true or not. And if so any split we are doing either at 0th, 1th position, 2th position, or somewhere. So anyone should hold this property as true because we are solving sub problems. So let's try to do in recursive way, and we will use the memoization uh, to because we want to know from I to jth index whether it is true or not. So we don't want again and again compute the answer. So we will do the memoization for that. So let's try to take a look. Uh, so here we will keep n nums dot size, and after that we will maintain a dp. So we will keep dp new int same size n plus n matrix, and we will keep one prefix sum also. So prefix sum is just for doing the sum to identify sum from I to jth index in O of 1. So new and Here we will take this one base indexes. Uh, so n plus 1 will be required. So let's try to pre-fill the DP less than n plus I. So here first we can do the prefix sum also. So for ith we are taking, because it is one based, so we are taking I plus 1. So previous one is I plus this current number. So now, okay, and obviously we are going to fill DP as -1. So here we are going to keep three state here. -1 means uh, we have to calculate the answer. We have to calculate answer, and then 0 means not possible. 1 mean 1 means possible. So here we will go till n plus j. So here first we will, what we do, I j we will fill with this -1 not calculated. But if we take a look at this condition, length of the subarray is 1. So for one length we will have always answer as true. So we have to consider I equal to j in those scenarios. What we will have to do, we will have to mark it as 1. Answer is possible. Then we will maintain a we will calculate these things in separate functions. So separate function will be boolean can split. Okay. Here we will take from x index to y index, and obviously we will consider m also, and we will pass this num list also, nums, and we will pass a prefix sum also. Okay. So what we have to do, we have to just call this function from here, return, because we have to return boolean, can split and left and right index. Here instead of x and y you can consider l and r, left and right. So initially the left will be 0 and right will be n minus 1, and m will be same, nums, and then prefix sum. So we are passing this one. So first we will check if L is greater than equal to R, then obviously the answer is true. Okay, and now we have to consider this thing. If dp of, sorry, here we have to pass dp also. So because dp is for memorization purpose, so we will pass this here, this 2D array and dp. So what we will do, we will check whether L and Rth position dp not equal to -1 means it is already calculated. Then we have to return. If it is 1, then obviously the answer is there. If it is not 0, we have to consider that one. dp of L are not 0, so it should be greater than 0. So it will return true. Now coming to next part, what we have to do, we have to figure out the answer. So we have to split from left position, and we will move till right one, I plus plus. So here what we are going to split into two parts. So uh, is possible. So here in is possible, what we are going to do first, obviously these two things we have to consider. So here first thing is so there are two conditions. First is if length is 1, because length is 1, either length is 1 or sum should be greater than this value. So first we will for that what we can do. So initially we are taking this as true, and we will go one by one. Is possible is equal to mm, is possible and condition. So first the left part. So left part is L to I. Okay. So means I minus L plus 1. If it is equal to 1, so length is 1, then obviously it is holds true. Else we have to move to other condition, and where we will check sum. So prefix sum till ith index. So here it is 1 base index. So minus prefix sum L. Okay, it should be greater than equal to n. Okay, so first condition we have checked this one, and obviously we will also check this. Call the function recursively can split. Left part will be L and right part will be till ith index, and M will remain same, arms will be same, and then prefix sum, and then dp. Okay, now we will move to the right part. Same thing. What we have to do, we will let copy this part. Okay, now we will check the right part. So right part is y, sorry, r, right side, minus I. So I we have to include exclude. So here we will check whether length is 1, or the prefix sum we will consider r plus 1 and the I plus 1. So this will be the for right part if it is greater than equal to 1. And similarly we have to do for right part recursive calculation. Now the thing is here we have to consider from I plus 1th index to right part, and M will remain same and rest will remain same. After each any of the split at ith position, any ith from between L to R, if it is possible, then obviously we will consider this as the answer. And what we will do, we will mark this L and R as 1. The answer is calculated and it is possible, and we will return true. If it is not possible, then obviously we will mark L and R dp as 0, not possible, and we will return false. Okay, so I think this will be the here. Let's pass dp here. Okay, now it should work fine. So let's try to go through it. We have taken n size, and we had taken dp, their prefix sum, and we have calculated the prefix sum and dp initialization. Then we have called 0 to n minus 1 and rest other parameters. And here we have checked if it is greater than equal to r. So it means although greater than will not be possible, but equal to will be possible. We will return answer as a true, because for one length it will be true. And if it is already calculated, then we will return the answer. If it is not calculated, then obviously we will move from left to right, and left to right part, and we will check first either one of the condition holds, either the prefix sum is greater than equal to m, or the length is 1, and then we call it recursively. So And similarly, if we are going to do that for right part also. So here, if we consider the right part, we have taken this same conditions with right, and right will start from I plus 1 to R. So let's try to run it. Okay. Okay, it is working fine. Thanks for it.